When light interacts with matter, we distinguish two scenarios, absorption and emission. Let's look at the absorption first. When a photon is absorbed by material, the photon is annihilated and its energy is added to the internal energy in the material. Let's plot the internal energy vertically. Initially, the material has low energy and is in its ground state. A photon is absorbed and causes the transition of the material from the ground state to a state of higher energy, an excited state. Emission next. If a material is in an excited state, it can release the energy of the excited state via a photon and emit a photon. The internal energy of the material is reduced, and the material returns to a lower energy state, for example the ground state. In an energy diagram, it will look like this. Initially, the material is in the upper state. It transitions to the lower state by emitting a photon. Emission can be categorized according to what brought the material into the excited state in the first place. When emission occurs as a consequence of light absorption, we speak of photoemission or photoluminescence. Usually, the emitted light has a longer wavelength and a lower energy than the absorbed light. Some energy is basically left behind. Photoluminescence is also called fluorescence. A high visibility biking jacket is an example. If the luminescence continues after the excitation light has been switched off, we speak of phosphorescence. Indoor exit signs are a typical example. Next, when photonic emission results as a consequence of an electric current, we speak of electroluminescence. This occurs, for example, in LEDs. When emission occurs as a consequence of a chemical reaction, we speak of chemoluminescence. Examples are glow sticks and the pulsating light in fireflies. Lastly, if light is emitted by something that's been heated, we speak of thermoluminescence. Examples for that are incandescent lamps.